I welcome you all to the module 5. The module 5 is about memory and forgetting. So, in this module, we will talk about the different psychological understanding about the concept of memory and forgetting. So, today's lecture is lecture number 11 overall. So, and it is titled as memory types and functions. So, we will discuss about different types of memory and what are the functions of all these types. And this is the first lecture of this module 5. So, before we talk about today's lecture, let me give you a brief recap of the last lecture, which is lecture number 10. So, lecture number 10 was part of an earlier module that was about learning. So, in the lecture 10, we discussed the concept of observational learning, which is one of the types of learning that we discussed. We discussed classical conditioning, operant conditioning and observational learning. So, the last lecture was about observational learning, which is also called as social learning, modeling and so on. We also discussed the role of the different aspects of observational learning, what are the steps involved in it, what are the mechanisms involved in it, and we also discussed the role of self-efficacy in observational learning. We also discussed the concept of mirror neurons and what is the role in observational learning from the neurological perspective. We also discussed observational learning and how it relates to prosocial behavior and how it can be connected to antisocial behavior or some negative behavior in terms of we discussed it in terms of how observational learning can be applied in the real context in order to explain behavior such as how aggression in the media can influence children and so on. So, these are some of the things that we discussed in the last lecture. In today's lecture, we will talk about, since this is the first lecture of the memory module, we will give introductory concepts of memory, what is memory, the stage model of memory and the different components of this model like sensory memory, short term memory, working memory, long term memory. We will discuss all these aspects in today's lecture. So, let us start. So, when we talk about memory, how do we define memory in psychology? So, one of the basic definition involves memory refers to mental processes that enable us to acquire, retain and retrieve information. So, how do you acquire information, then retain it, and then whenever necessary, how do you retrieve those information from the brain or the brain through the mental processes. So, these are all mental processes connected to how do you acquire, how do you store and how do you retrieve them. So, that this whole processes are involved in the memory. When you talk about memory, it includes all these three aspects. So, psychologists consider memory to be the process by which we encode. So, the same term we can use it in more technical way. Encoding means acquiring, storing means retaining and retrieving means retrieving information. So, the same thing we can use the different terms, more technical terms. So, memory involves these three processes, one is encoding, storage and retrieval. Collectively we call these three processes as memory. Let us look into each of these three aspects, what is encoding, what is storage and what is retrieval. When we talk about encoding, it means you have to first transform whatever you see in the world through the sense organ and you transform those information in such a code that it can be stored in the brain. So, that is the encoding. So, transforming information into a form the memory system can use or store in memory. So, you see something through eyes, the visual world, then you store that visual images in the form of a code or image. So, that image can be stored in the brain. So, that is called encoding. So, whatever you see, whatever information you process, first you have to transform into a code that can be stored in the brain. So, that process is called as encoding. So, when we see, hear and experience something, our brain processes it, transform it into certain mental code, so that it can be stored. Brain needs to transform that information. So, for example, it could store information in terms of visual, sound, meaning. So, that transformation is encoding. Okay. So, typically we encode information, for example, whatever we see, the visual encoding. Whenever we see something, the brain transforms those information into a visual code. For example, you see a map and that image of that map is, you create an image of it and that image is, stored in the brain. So, that is the process of visual encoding. Whenever we hear something, that whatever we hear through our ears, that is also transformed into acoustic encoding, or we remember, let us say, a song by how it sounds, lot of things we remember based on how they sound, for example, music, songs and so on. So, you encode that information into certain acoustic form or acoustic code, and then it is encoded in the brain. Then it could be also it could involve other sense organs also, and then also semantic encoding, means remembering a concept because you understand it. So, whenever we process some information, we see some concept, we read it and then we understand it, understand the meaning of something. Then the brain encodes those information in the form of certain meanings. So, whenever we again see that those concepts, we understand what is the meaning of this. So, these are called semantic encoding. So, like this there can be different types of whatever information we see or process, they are encoded in a certain form in the brain to be stored. So, this is the first stage called as encoding. It could include all these types of encoding based on the modules through which we process information. Then comes the next step in the memory is storage, means now this is encoded, now you have to store it. So, keeping those or retaining those encoded information in the memory for later use. So, you store it, otherwise if you are not able to store those information, you will not be able to remember anything. So, we are able to remember a lot of things that has happened in the past because these are encoded and stored properly. Just encoding may not guarantee that you will be able to remember them, you have to store it, so that it can be used in the later whenever it is necessary. So, after encoding, the brain keeps the stored information so that it can be later used. So, brain can store it in some different types of storage system, like it could store in the sensory memory. So, we will talk about this in more detail. Here the memory is for very brief few seconds. You see something and for few seconds it is stored. So, those are called sensory memory. Sometimes this information can go to short term memory, where it can last for let us say 15-20 seconds, and if it is further processed, it can go to long term memory, where it can be retained for the years, months and maybe for the rest of the life, depending on how you processed it. So, this storage could be of different time duration depending on how you have processed them, how much attention you have paid to them. So, that is the storage. So, depending on what type of storage, we will be able to, whether we will be able to retrieve it later or not, depends on what type of storage system the information is stored. So, you for example, you study a concept today, it stays in your memory and that is keeping in the storage. So, you studied something in the book, you understood the concept, now you can remember it later at any time. So, this is that means you have encoded the information properly and stored it. So, the second part is called storage. The third aspect of memory is retrieval, means you have to again, if something is stored, memory also should be that you will be able to use them whenever necessary also. If it is stored and you are not able to retrieve it, then also it is not like many times it can happen, lot of things are stored, but you are not able to retrieve it whenever it is necessary. So, retrieving means you are able to retrieve or bring back those information whatever is stored in your brain. So, retrieval means bringing stored information into conscious awareness. So, it is remembering what you have stored earlier. So, it is not necessarily whatever is stored in your brain you will be able to remember it whenever it is necessary. There are many stored information, but when time comes you are not able to remember it, but it is still stored, but you are not able to bring it back. So, retrieval means you are able to consciously bring it back. So, retrieval may include recall, retrieving without cues, right. For example, you write an essay type question, answer of an essay type question. So, there is no cues, you just question is asked, you have to remember all the concepts and the details and examples and you have to write it. No cues is given for the answer. Okay? So, it may include recalling information, it may include also recognizing information or recognition. For example, identifying correct information. For example, in the MCQ type questions, there are certain cues are given already. You have to only identify the right option. You do not have to remember everything, because the options are given, you do not have to remember everything around it. Whatever seems right, you can just tick that. So, this is called recognition of information. Okay? So, retrieval may include recalling, recognition of information and so on. So, obviously, the recognition is much easier because you do not have to remember everything. Cues are given, it will activate whatever is necessary to answer and so on. So, for example, during an exam, you remember an answer you studied, this is retrieval. So, if you are able to remember whatever you have studied, then you are able to retrieve the information. So, the memory processes involve these three steps. encoding, storage and retrieval. So, these three processes kind of whenever talk about memory in psychology, it includes all these three aspects. So, we can use this analogy of this computer system to understand these three processes of memory, encoding, storage and retrieval. So, for example, if you see the keyboard here, it is used to encode an information. So, in the computer keyboards are used. So, you want to give them some data. How do you give data to a computer? Through keyboard, you write and give whatever information that is needed, okay. And that information gets stored in the storage or hard drive. Okay. So, here encoding is happening, here storage is happening, and then whenever we want to retrieve those information, then we use the screen or whatever. So, that stored information can be retrieved here. Whatever is stored, how do you know how then retrieval only happens in the screen only. So, screen helps us to retrieve those information and identify what is that information. So, it is similar process, encoding, storage and retrieval. Similar things happens in our brain also. So, that is the whole process of memory system. Now, psychologists view memory as a part of continuum of information processing. So, our brain does different varieties of information processing, starting from attention, sensation, perception, learning, then comes memory, which then extended to thinking, problem solving, language, intelligent behavior, decision making and so on. So, brain does multiple functions from very simple to very complex processing. Memory is also comes into all this, one of the concepts around all these processes, okay, which may include lot of other cognitive processes. For example, attention is required for memory. Memory also is connected to learning and so on. So, it is a part of this whole continuum of different processes that brain does. One of the important aspect is memory, which may include other aspects of the cognitive processes. For example, for problem solving, for thinking, you need memory. Without memory, you cannot solve a problem, So, these are all interconnected concepts, and memory is one such concept among all these concepts. Now, evolutionary psychologists view memory as a component of the neural mechanism designed to use information acquired in the past to coordinate an organism or behavior in the present. So, evolutionary memory is very important. It helps us to survive in the world, it helps us to function better. Think for a moment that you do not have any memory of the past, whatever has happened, you will not be able to understand how to take a step further, because you do not have any information what you have done in the past. It is because of the memory we know what should I do, because we have learned many things in the past, and those learning you do not have to learn again and again, because it is already there in your memory. So, every time you do not have to learn a new thing and again take a new step and so on. So, that is not required, simply because everything is stored in your brain. So, whenever a situation arises, whatever you have learned past, it will get activated and it will help you to solve the problems in the present context. So, the evolution of memory provided crucial survival advantage. It allows us or animals to use past experience to respond rapidly to the present challenges, because they have multiple time of experience, let us say around any situation. Whenever such situation arises in the future, they do not have to again work it out again and again, because they know what they have done earlier and what kind of actions has worked out. So, they can immediately do those actions, because this has been successful in the past and so on. So, memory helps us to survive, function better in the world. Without memory, we will not be able to survive and function in the world. So, memory help us to treat, for example, instead of treating each predator or food source as new, the animals with memory could react more efficiently, saving valuable time. For example, for any animals, whenever they see, for example, for a deer, the moment they see lion, they have this memory that this is a dangerous and that it can attack me and so on. So, they will immediately take the necessary step, rather than exploring whether this will attack me or not, because they have this memory of that this animal can attack. So, they do not have to treat each time a predator a new information or new stimuli and so on, not necessary. So, that memory helps us to save time, survive and function better in the world. How are memories processed? So, let us now look into the details, mechanisms and the different types of memories that we have in our brain. One of the most prominent models in the world of memory or psychology of memory is something called as a stage model of memory. So, there are stages involved in the how information is processed and goes from one step to another step when we process as information and store it in our brain. So, this is called as a stage model of memory. So, obviously, no single model has been shown to capture all the aspects of memory. So, there is no perfect model anywhere. These are like the best model that we can use to explain things, No model is perfect, there are issues in every model still. But stage model is one such model which has been able to, which has received lot of empirical evidence, and it seems to be a very, good model to explain human memory. However, this very influential model, the stage model of memory proposed by Atkinson and Shiffrin in 60s and 70s, also called information processing theory. This model is also called as information processing theory model. It is useful in explaining the basic working of memory. To understand how memory works in a very simple and basic way, this model is very useful and helpful. So, we will talk about this model. Obviously, this model has been continued to be modified from this original model, while the basic aspects are still retained, that the stored for different lengths of time and that execute control processes and influence the system. But the basic processes are still are retained, but there are many modification has happened around this model. So, if you see this model in a very general sense, what it talks about. So, there are three types of memory, three stages in which the memory or information is processed when we store an information or retrieve an information. Okay. So, in terms of storing an information, it starts with something called as sensory memory. This is the memory that is captured by our sense organs. Like whenever you see something, there is a visual information. So, our eyes, sensory organs captures it. So, it captures it for a very brief moment of time, but still it is a memory because it is captured, it is stored. Although thus the information is stored for a very brief time, maybe for 1 second. So, this is called as sensory memory. For example, whenever we hear, our ear can the moment we hear it, it is also retained for some time, very brief moment of time. So, the initial process is whenever we see an information or hear an information, whenever we see any data, the first step in memory is called sensory memory. So, here environmental information is registered through sense organs or through processing of information. It has large capacity of information, it can capture lot of information, but the duration is very small. It could be less than 1 second to 3-4 seconds. Since our sense organs can capture information for a very brief moment of time, but it can capture a large amount of information. So, we will talk about it in more detail. So, this is the first step. The moment we pay more attention to the information that comes through sensory organs or sensory memory, if we pay attention, then this information will get shifted to the next memory called as short term memory, which has been renamed later as a working memory. We will talk about that. Now, short term memory, here the new information is transferred from sensory memory to here because attention was paid. So, little bit for more time it will be stored here because you have paid more attention. Old information is also retrieved from long term memory. So, that is the concept of working memory. So, we will talk about that later. Now, this has very limited capacity of information and the duration can be for about 20 seconds. Sensory memory can capture lot of information, but then it stays for a very brief moment of time. But when little bit of attention is paid, it is transferred to short term memory. Here the capacity is very less, but it can capture the information, some information whatever we see or observe for little bit more time, maybe for 15-20 seconds, and then if you rehearse that information, process it further, then it will go to long term memory. Now, that information that has been encoded in short term memory is stored, means if you have processed the information whatever is in your short term memory, rehearsed it, processed it properly, then this information will go to long term memory, where it has unlimited capacity and it has potential for permanent storage. So, if you have processed an information properly, you will remember it for probably the rest of your life, that is a probability. So, that is called long term memory, because for long term time you can store an information in this and it has unlimited capacity. You can store almost unlimited information in the long term memory. So, this model says this is the flow of information. So, the information is captured first in the sensory memory. If attention is paid, it goes to short term memory, because this time duration of the storage is different in each category. Here it is less than 1 second to 3-4 seconds. When it goes to short term memory, it is about 15-20 seconds. When it goes to long term memory, it can be potentially very long time. You can store the information for the rest of your life also. You can almost like permanent storage can also be done here. So, these are the 3 stage or 3 stages or 3 processing that happens when an information is captured and how it processed and go to the from sensory memory to short term memory to long term memory. So, this is the whole idea of stage model of memory or information processing model of memory. Now, let us look into each of these modules of this memory. The first one is sensory memory that we discussed. What happens here? Sensory memory is the initial momentary storage system that briefly holds information from the environment before it is either fades or moves into short term memory. So, in the sensory memory, as I said, it is just initial capturing of an information and storing it for a very brief moment. Either it fades or it goes to the short term memory, depending on if you pay attention or process the information properly, then probably it will go to the short term memory. If it is not paid attention, it will fade away after maybe within 1 or 2 seconds. So, that is the sensory memory, just capture the initial information for a very brief period of time. So, it captures sensory input with high precision. So, sensory organs capture something with high precision, but the problem is it stays for a very brief amount of time. To take it to the other short term memory, you have to pay attention, process it further, but the duration is very limited. So, there are different types of sensory memory for different senses. So, whatever sense we have, accordingly we have one sensory memories. For eyes, we have iconic memory, whatever we see and store it initially, that is iconic memory. Whatever we hear, we store it for a brief moment of time. So, that is echoic memory. Similarly, there can be sensory memory for touch, smell and so on. Okay. So, for example, it can be iconic memory, stores visual information and lasts less than a second or around 1 second. Whatever we see, it is stored for less than a second or 1 second. So, whatever we see through the eyes, if you do not process it further. So, it will only stay for maybe 1 second or less than a second. Then comes echoic memory, stores auditory information and fades within 2-3 seconds. Auditory information lasts little longer, whatever we hear, it stays for 2-3 seconds. Similarly, brief sensory memories exist for other senses as well. Whatever we smell, whatever we touch, there also the information stays only for brief moment of time. So, whatever sensory organs catches information, their duration of storage is very small, and but they can have large capacity and they can precisely store information, exact replica of information. So, that is called sensory memory. So, despite brevity or short duration of storage, sensory memory retains almost exact replica of the original stimulus. Whenever we see something, when the information is in the sensory memory, it will exactly catch whatever we see for a second. Obviously, when you process it further, it can get distorted and so on. But when it is in the sensory memory, it captures exact replica of what you see, what you hear. Now, George Sperling, he did some classic experiments in the area of sensory memory, particularly iconic memory, the visual memory, that whatever we see, how it is stored in the sensory memory. He did some of the classic experiments. So, we will talk little bit about some of his experiments. George Sperling conducted groundbreaking series of experiments that provided empirical evidence for the existence and duration of sensory memory. What is the proof that sensory memory exists? This were proved by some of these classic experiments, that there is an existence of sensory memory and why it has a short duration of time, what is the time period it in which the information is stored in sensory memory. How do we know all this information? Lot of this information comes from this such groundbreaking experiments. So, let us see some of this experiment, how they prove that the existence of sensory memory and why its storage time duration of storage is very small, particularly for the iconic memory. George Sperling did lot of research. Now, Sperling wanted to determine how much visual information can be stored immediately after seeing a stimulus. Second, how long does this information persist before it fades? So, he was interested if there is a sensory memory, particularly for visual information, because that is the most important sense organ through which we capture data from the world. So, he was interested how much information can we capture through sensory organs, particularly through the visual memory, and how long does it stays before it fades, because we are now only interested in the sensory part. Obviously, when it goes to short term memory, that is a different story, but when it is in the sensory memory, for how much time it stays and how much capacity it has in terms of storing information. So, these are the research questions he was interested in, and he did experiment to find out the answer. He briefly exposed people or participants to a series of 12 letters arranged in the following pattern. So, he used this kind of stimuli where letters, 12 letters are arranged like this in the 3 rows. These are all English letters randomly arranged in the 3 rows. So, he exposed participants this type of stimuli. So, he used 2 methods. One is called as hold report method. What is hold report method? Here participants were briefly, very briefly, less than a second, about 1/20th of a second, in a very flash, in just like a flash, it was shown this kind of matrix of 3/4 matrix of 12 random letters arranged in 3 rows, very brief moment of time, less than second. Okay. Immediately after it was flashed, participants were asked to recall as many letters as possible. So, that is called hold report, means whatever you remember, you just report it. So, it was flashed for a very brief second and immediately it vanished, and then they were asked report how many letters you can remember that was flashed. So, that was the experimental method that was used. What was the finding? On average, participants could recall only 4 to 5 letters out of these 12, even though they reported seeing all or most of them. Participants said we could see all of them, but they could report only 4 or 5 letters out of these 12. That means, others faded away, immediately it faded from the memory. This suggested that all the letters had entered the sensory memory. So, that means, sensory memory could capture all the letters, but immediately they faded, but most faded before they could be reported. The moment they started reporting, the other letters faded. They could hardly report 4 or 5 letters, and all the other letters faded the moment they started reporting it, because some time was spent. So, since Barbell report takes time. So, that was the finding of this experiment. So, from the whole report he could find that sensory memory can capture almost all the information. It was captured by the sense, all the 12 letters, but since it lasts so for such a brief period of time, the moment they started reporting, they forgot most of the letters and they could report 4 or 5 letters. Then he used another technique to get more answer. He used partial report technique. To test whether the full array was initially stored in memory, Sperling used an ingenious method. In the whole report method, participant only said that they could actually all the letters were captured by their eyes, but they could report only 4 or 5. Whether that information is correct or not, just to confirm that he used partial report technique. What is that report now? The same 12 letter grid was shown for a very brief short time, less than a second, briefed and then vanished, briefly shown and then vanished. Immediately after the display disappeared, a tone was played. Here now the experimental method changed a little bit. Here they were not just asked to, somebody did not ask to report whatever they have seen, that was the whole report. Here they were asked that depending on what kind of tone was sounded, they have to report particular row of those letters. So, there were 3 rows. If high pitched tone was sounded, they should recall only top row. If medium pitched tone is sounded, or if sound of a medium pitched tone comes, they should only report middle row. If low pitched sound is produced, then they should only report bottom row. So, now he was just clarifying whether they were able to capture all the letters that were shown or not using this method. Now, this time they were not supposed to report everything they could remember, they were supposed to report a particular row, because there were 3 rows. Here there were 3 rows. So, this was the first row, middle row and bottom row. So, they were supposed to remember depending on the sound intensity that was given to them after the after flashing those letters, depending on that they are supposed to report either top row, middle row or bottom row. So, tone was sounded after the visual display, immediately after the visual display, meaning participants had to rely entirely on memory to report the cues. So, they are supposed to report entirely from their memory only. What was the finding here? Participant could recall the entire cued row accurately, no matter which row was indicated. This time he found they could easily report whatever row was asked from them, top row, middle row, bottom row, entire row they could report. This meant that the entire 12 letter was initially stored completely and accurately in memory, at least for a short duration. Now, since they are not supposed to report 12 letters, because reporting 12 letter takes time, and in that time lot of this information gets fade away. Now, to reduce that, he used partial reporting method, where they are not supposed to report everything, only 4 letters, top, middle or bottom row. This time they could report accurately whatever row was asked to them. So, that means they could, all the informations were stored, and since it took less time to report 4 letters, it was still retained in their memory, sensory memory, they could report it. For reporting 12 letters, it took more time and they could not report, because lot of these other letters got faded away. So, this partial method report clearly indicated that all the 12 letters were captured in the sensory memory, they could store it, and since whatever row was asked to them, they could report it, and so that means all the information was there, and since 3-4 letters they could report within those sensory memory time limit. So, they could report it. So, accurately memory at least for short duration. So, since sensory memory fades so quickly, participant could not recall more than 1 row once time passed. More than 1 row they could not report, because after that the other information gets faded away very quickly. So, this experiments showed. Now, further he kind of used a lot of variation to this experiment by gradually lengthening the time between presentation of the visual pattern and the tone. Slowly he strengthened the time. Initially, just after the flashing, immediately it was tone was sounded to report, then the experimenter increased the time period. As they increased the time period, Sparling, he was able to determine within some accuracy the length of the information, length of the time the information was stored in the sensory memory. So, changing the time period, he could easily find out how much time the information is stored in the sensory memory. The ability to recall a particular row of the pattern when a tone was sounded declined progressively as the period between the visual exposure and the tone increased. As the time period was increased for the reporting, the accuracy went down, because even for 1 row also they could not report, because it faded away. So, decline continued until the period reached about 1 second in duration, at which point the row could not be recalled accurately at all. After 1 second of gap, the participant could not recall even accurately even one row. So, that means he could kind of understand from all this changing time period that the visual information or the iconic memory is stored for at least for 1 second. After that it fades away. So, Sperling concluded that the entire visual image was stored in sensory memory for little less than a second or a second. So, that was from this experiment they concluded that the time period for which the sensory memory, particularly the iconic memory or the visual memory is stored is for around little less or about 1 second. So, that was about sensory memory. Now, comes to the short term memory. Now, information moves from sensory memory to short term memory based mainly on attention. So, whenever an information comes to the sensory memory, if you pay attention to the information, it will move to the short term memory. If you do not pay attention, it fades quickly within a second, or whenever you hear something within 3 or 4 seconds. So, the key here is attention. If you pay attention, the memory moves from sensory memory to short term memory. Now, the short term memory is a temporary storage again. It is also not a very stable storage. It is a temporary storage system that holds a limited amount of information for brief period, typically 15 to 30 seconds, unless actively maintained or rehearsed. So, the information, if you pay attention, it moves from sensory to short term memory, and their information stays for about 15 to 30 seconds. So, it will only stay for that amount of time. If you process it further, like you rehearse it, process it further, then it will go to the long term memory, otherwise it will fade away. So, it acts as a mental holding area. You just hold the information for enough time period to process it further, to take it into long term memory, or either it will fade away. So, it is a kind of mental holding area between the sensory registers and the long term memory. So, this is a intermediate step between sensory and long term memory. You hold the information, and depending on how you process it, it will go to long term memory or it will fade away. So, that is called short term memory. What is the capacity of short term memory? Short term memory capacity is generally very less as compared to sensory memory, which may have large capacity. It can immediately capture lot of information, but it fades very quickly. In case of short term memory, the information that it can hold is actually very less. So, let us see what is the capacity and how it was found out. In the seminal paper titled The Magical Number 7 plus minus 2, Some Limits on Our Capacity for Processing Information, George Miller in 1956 argued that capacity of short term memory is 7 plus minus 2. So, capacity of short term memory according to George Miller is 7 plus minus 2. So, that means it could be 7 plus 2 or 7 minus 2, means it could be 9 or it could be 5. It ranges from 5 to 9. How did he find? Miller observed that the people can recall about 7 items, digits, letters or words when tested on short term memory tasks. When people are asked for or to remember digits, letters and words, and they were tested for short term memory tasks, generally they could report about 7 items, not more than that, 7 to 9 items. However, he noted that what counts as a unit or item can vary depending on how information is organized. Now, what is the unit? So, it can store information as 7 plus minus 2 units, not one individual items. One individual item can be a unit, or you can have 2-3 items in one unit, depending on how you cluster it. So, it is unit, not the particular one item, it is about the one unit. So, unit vary depending on how information is organized. For example, remembering a string of 9 random digits, for example, 4, 9, 2, 7, 6, 1, 3, 8, 5. So, these are 9 digits if you are asked to remember, you can try to remember individually one by one, then you have to remember 9 units. On the other hand, let us say you find a trick to make it smaller by creating some similar patterns, like 492 one pattern, 761 is another, 385 is another, something like this. So, now this 9 letter is now converted into 3 units only. It is much more easier to remember, because rather than remembering 9 units, you are remembering only 3 units. So, you are more, it is much more easily you can remember it. So, it is easier because the information is chunked into meaningful groups. A lot of people remember phone numbers like this, because as the number of unit increases, it is difficult to remember, and short term memory has a very small capacity is small. So, according to this research, 7 plus minus 2 is the capacity of short term memory. So, it is from 5 to 9 units we can store in the short term memory for 15 to 30 seconds for further processing. So, this process of clustering items on certain meaningful patterns is called chunking. Chunking enables individuals to encode multiple pieces of information as a single unit, effectively expanding the functional capacity of short term memory. So, one can increase the capacity of short term memory by chunking the information. For example, here 9 items can be converted into 3 items or 9 units into 3 units by chunking the information. So, you could increase the capacity. Now, you can add more units. So, you can increase the capacity of short term memory by chunking the information or clustering the information. For instance, a chess expert can remember many positions on a chessboard by grouping pieces into familiar configurations, whereas a novice cannot. So, this is probably how expert chess player and a new chess player different, because an expert chess player can remember positions on a chessboard by grouping into certain patterns and so on. They can kind of find out what will be the pattern in so many moves. So, that happens because they are able to chunk information and cluster them in certain ways. However, from this there was some revision done later on, or refinement was done on kind of this capacity of 7 plus minus 2 storage capacity of short term memory. Some later research challenged Miller's numerical estimate, that is 7 plus minus 2. It was challenged, arguing that the true capacity of STM could be actually less than that. It may be less than even 7 also, less than even 5 also. So, this Nelson Cowan's 2001, he made some research which showed that there was an influential paper that was published, the magical number 4 in short term memory. So, he said actually the capacity of short term memory is 4, not 7 plus minus 2. So, Cowan reviewed the decades of experimental evidence and concluded that the core capacity of short term memory is closer to about 4 chunks of information, not 7. So, he said actual capacity could be actually less. How did he come to this conclusion? So, he found that if we control for rehearsal and chunking, if you just give them raw information for short term memory and do not give opportunity to the participant to chunk or to rehearse, then obviously the capacity increases and so on. If that is removed, then actually capacity goes down. Miller's original studies often did not control for rehearsal and chunking. Whatever original experiment that was done by the Miller, which found that the capacity of short term memory is 7 plus minus 2, he did not control that whether the participants are chunking it, so that the capacity actually is increasing, or maybe the participants were rehearsing to keep it for longer time and capacity increased, that was not controlled. So, Cowan tried to control that. When participants use these strategies, they effectively expand memory capacity by linking item into meaningful groups or by rehearsing them repeatedly. When such strategies were prevented, for example, by introducing distraction task, recall performance dropped sharply to around 3 to 5 items. So, if they are participants after presentation, they were given some distraction tasks, so that they are not able to rehearse them or chunk them, they were not given this opportunity. Then their capacity actually went down to 3 to 5 items, which Miller says it will be 5 to 9 items. So, it decreased a little. So, Cowan's view actually does not contradict the Miller's finding, but he only reinterpreted it based on removing the effect of rehearsal or chunking and so on. He reinterpreted Miller finding of apparent capacity of short term memory could be what Cowan estimated as the pure capacity of the cognitive system. So, Miller's 7 plus minus 2 could be called as an apparent capacity, means there may be some rehearsal, something that generally we do that may lead us to 7 plus minus 2 capacity, but pure capacity, if that is prevented, then it may go down to maybe 4, 5 information can be stored in the short term memory. Today most cognitive psychologists accept that the average short term capacity is about 4 plus minus 1 chunk. So, that means 5 to 4 chunks of information when rehearsal and chunking are minimized. Without rehearsing or chunking, maximum we can hold capacity of short term memory could be 5 to 4 chunks of information. This capacity can appear larger when individual use meaningful grouping or expert based strategies. Some rehearsal when it is done, the short term capacity could increase up to 7 plus minus 2. So, both are correct, but depending on the context it could be 4 plus minus 1 or 7 plus minus 2. So, these are the research that showed the capacity of short term memory is actually limited. You can increase that capacity by chunking the information or grouping the information into more meaningful patterns and so on. Now, there is another concept which is connected to the short term memory, or short term memory was later renamed as working memory just to introduce some new ideas in the short term memory. So, that is called working memory. Now, working memory is not completely distinct from short term memory, only the conceptualization of short term memory has been changed using the concept of working memory. So, it is a term used by Miller et al. In 1960 to refer the memory as it is used to plan and carry out a behavior. Now, after Baddeley and Hitch 1974 showed that a single system could not explain all types of temporary memory, the concept of working memory gained prominence. Now, Baddeley and Hitch found that short term memory, just one module as a short term memory, could not explain lot of functions of temporary storage of information, which short term memory does for 15 to 30 seconds. It could not explain lot of other aspects of temporary storage of information, how it manifests, it could not be explained. So, they introduced the idea of working memory to explain all the other possibilities of storing information for short term. So, this working memory came from there. Their work led to influential model proposed by Baddeley and his colleagues, proposed that verbal, phonological and visuospatial informations are stored in a separate subsystem. The initial short term memory concept was very clear, one just module where all the information from sensory memory get transferred to one memory system called short term memory system. They found this cannot explain lot of things. So, they found that within the short term memory there can be different modules or different subsystems, where visual information when it is transferred from sensory memory to short term memory, it is handled by separate visual system, visuospatial system. Auditory information is again handled by another system. Within the short term memory there can be subtypes according to working memory concept. So, they found verbal phonological means auditory information and whatever we hear in terms of verbal information, and there is a visuospatial information means whatever we see, visual information are stored in separate subsystem. Within this temporary storage system there are subsystem for visual information and a separate system for auditory information, and both these systems were regulated by something called as central executive. So, initial model had 3 components. There is a visuospatial component, there is an phonological or verbal phonological component for auditory information, visuospatial for the visual information. These are 2 separate systems, and central executives controls both of them, kind of processes information from both of these subsystems. So, that is called central executive. So, initial model had 3 components within those temporary storage of short term memory. So, in this system obviously later they included one more system that we will talk about. So, rather than being only short term memory as an independent substation where memory just arrives, either fades away and then either or goes to long term memory, temporary most of the evidence shows that short term memory is far more active than just passively taking information from sensory memory, or from their short term memory either it fades or go to the long term memory. It is a very passive system concept, but they found in real life short term memory could be much more active. So, this working memory help us to explain all the other aspects. So, in this view Short-term memory function as an information processing system that manages both new material gathered from sensory information and older material retrieved from long-term storage. So, short working memory, the conceptualization is that it is a very active system. So, one way information is coming from the sensory memory, visual or hearing, whatever you get it. Another way information is also getting activated from the long-term memory, whatever we learned in the past, that is also coming to the short-term memory. So, short-term memory is like holding area active system that is taking information from sensory memory, long-term memory and actively processing it with different subsystems. So, that is the concept of working memory. So, this increasingly influential view, short-term memory now is referred mostly as an working memory. So, working memory is the system that temporarily holds information while actively manipulating and rehearsing it. So, according to working memory, this is not a passive system. Here information is held in the short term space, but then actively it is also manipulated, information is manipulated in the working memory space. So, using this computer analogy, working memory represents the processing that occurs in an open window on your desktop. In contrast, the long term storage of information in the computer's hard drive, So, like it takes information from sensory memory and all the long term memory and holds it and actively processes it. That is more realistic and in line with whatever we see how people function. So, this whole model of Baddeley and Hitch provided the model of working memory, which is called as a multi-component model. What are the things included? Some of these things we have already discussed. So, this is an upgraded conceptualization of short term memory, and so there is a multitasking system that actively manipulates data rather than just holding it. Initial short term memory concept was just holding the information. Working memory says it not only holds, it also actively manipulates the information. For example, you can hold some figures in your mind and calculate, you can do addition, subtraction. So, you are still holding it in a short term space. So, that is what working memory is all about, that it is an active system, not only holds information, but actively processes it. So, in the multi-component model, what are the components? The first one is obviously the central executive. This is the boss of the system. It controls other subsystems. It does not store information itself. This is more like processor. If you see processor in mobile or computer, so there is a processor that processes the information. It does not store information, but it directs the flow of data. So, it focuses attention, switches between tasks, coordinates the slave system, whatever the other system that we will talk about. So, it is like a traffic controller deciding which plane lands on which runway and so on. So, it is like decision making, manipulator of the information, whatever comes in other subsystems. So, this is called central executive. Then comes phonological loop that we talk. Phonological means all the auditory information that comes from the sensory memory. It handles auditory and verbal information. It is subdivided into phonological store, like inner ear holds spoken words for 1 to 2 seconds. Whatever we hear from someone, it holds it for some time, 1 to 2 seconds. It also has articulatory process, inner voice rehearses information so that it does not fade away, like repeating a phone number over and over in your head. So, that is called articulatory process, inner voice that we rehearse it and so on. So, that is called phonological loop. Basically, it takes information from the whatever we hear, verbal informations or auditory information. So, this is a subsystem in the working memory. Another subsystem is the visuospatial sketchpad. As the name suggests, it takes information, all the visual information. This is the inner eye. It stores and manipulates visual and spatial information. Whatever we see, visual information from the sensory memory, it goes to the visuospatial sketchpad. If you are mentally counting the windows in your houses or navigating a map, you are using these systems. For example, if you close your eyes and navigate a map where which places are in which part of the map, you are using visuospatial sketchpad. So, it is like deals with spatial and movement information and so on. So, all the visual informations are handled by visuospatial sketchpad. After 2000, they also introduced something called as an episodic buffer, another component subsystem. Now, episodic buffer in 2000, Baddeley added a fourth component because the original model could not explain how the different subsystems talk to each other or to long term memory. Now, only visual information is coming to the visuospatial sketchpad, auditory information is coming to the phonological loop, but how they talk to each other. Now, central executive can manipulate whatever is given in the information, but how they talk to each other and what are the whatever information comes from long term memory get activated, how all this kind of connect with each other. They could not explain it using the 3 component model. So, they used episodic buffer as a 4th component. This episodic buffer acts as a temporary storage space that integrates information from the phonological, visuospatial sketchpad and long term memory in a single coherent episode or story. This is where all the informations are stored collectively together as a coherent episode. Whatever you see, whatever you hear, whatever is coming from your memory, long term memory, all in a coherent story, it is stored in the episodic buffer. It has a limited capacity, but provides some kind of backup, store that communicates with both working memory and long term memory. So, they added this 4th component to explain few research finding which could not be explained by the 3 component. So, this is an episodic buffer, and overall central executive decides where to pay attention, how to kind of decide what to respond and so on. Central executive kind of processes all the information in all the 3 subsystems. So, this multi component model explain why we can do 2 different tasks at once, like driving and listening to a podcast or music, but struggle with 2 similar tasks like reading a book while someone is talking to us. This multi component model can explain lot of things that we do in our real life. It can explain we can drive and listen to music, for example. There is no, it does not conflict with each other. Easily one can drive and listen to music. Now, but it becomes more difficult to read a book when someone else is talking to you. So, someone else is talking to you, you cannot read a book, because then there is a problem. There is some kind of conflict happens and you cannot focus on both the aspects together. So, this can explain why this is happening. Since the understanding, whenever another person is talking to you and you are reading, in both the situation you are using phonological loop, one system. So, it is trained, one system has limited capacity and both the information is coming to one system. You are reading verbal information, you are reading something, it is processed in the phonological loop, someone is talking, you are hearing, both are coming to the same system and it has a limited capacity. So, when both takes resources from the same system, your resource gets strained, you are not able to, you get distracted, you are not able to function in any of the task. But when you let us say driving, which is about seeing the road and so on, and music which is hearing, both are 2 different systems. No, they are not conflicting with each other, they are not taking resources from the same system, they are taking resources from the different system. So, you can easily drive and listen to music. So, that is what happens, that is what it can explain when sometimes multitasking you can do it, sometimes you cannot do it. So, that aren't actually multitasking in the new way we think, we are either using 2 different systems at once or poorly toggling between 2 tasks that uses the same system. So, whenever 2 tasks that require same system, you will struggle with it, you have to do one then again one. Simultaneously multitasking can be done when you are doing tasks that requires 2 different systems. So, these are some of the things that can be explained using this model. So, working memory allows temporary storage and also manipulation of information. So, that is how it is different from the concept of short term memory. Short term memory is only about storage of information. So, such as solving multi-step arithmetic problems or calculating something mentally, it consumes significant cognitive resources which can reduce situational awareness. So, when you are using short term memory or using resources, let us say calculating mentally, then obviously other awareness of the situation may decrease, because your whole resources are going into certain systems. So, for example, engaging in a demanding phone conversation while driving can impair attention due to working memory overload, because you are too much get resources engaged in one particular conversation, then for other things you will have very little attention to do it. So, that is why there is an overload in the working memory system which can reduce your capacity or efficiency in certain other tasks. For other things also can impair the capacity of working memory, like stress impairs working memory. Whenever you are highly stressed, your working memory goes down capacity, by decreasing the capacity. Research indicates that individuals with the highest working memory and mathematical ability are often most affected under performance pressure, leading to reduced efficiency or choking during the test. So, their working memory, because of the stress, it is not able to function properly and its capacity decreases, and that is why many times you are not able to mentally do lot of tasks that you are generally able to do when you are under stress and pressure, because the working memory capacity decreases. So, short term memory versus working memory, we have understood that these are like initial concept of short term memory, because short term memory could not explain lot of real life functioning. So, the working memory was conceptualized as an extension of short term memory, or you can say short term memory was renamed as an working memory in terms of newer evidences. So, working memory is more used in the concept of storage as well as manipulation of information, holding and processing of information for complex cognitive tasks. So, it is in a tabular form, all the differences are shown. When we use the word short term memory, it is both are temporary storage, short term memory and working memory, but here manipulation of information is also included, which is not included in short term memory. Short term memory is a generally passive holding of information concept. Working memory talks about active processing and using of information for task, actively processing. So, this is a short term memory was part of Atkinson and Shiffrin's stage model that we discussed. Working memory was introduced by Badley and Hitch in 1974 in a multi component model that we discussed just now. Short term memory is a single unitary store, there is no subsystem. Working memory has 4 subsystems: phonological loop, visuospatial sketchpad, central executive and episodic buffer. Role of attention is very minimum in short term memory. Here very central role, it is controlled by central executive. Storage capacity is 15 to 30 second here. It is also same here almost short term, but maintained through active rehearsal and processing. It can be maintained through active rehearsal and processing. It acts as a temporary holding area before it transferred to long term memory. Short term memory is just holding area. Working memory acts as a mental workspace for reasoning, problem solving and comprehension. So, it can take information from long term memory as well as from sensory memory, and it takes all the information necessary and manipulate it to solve problems, make decisions and so on. Short term memory example is remembering phone number briefly. Working memory, solving a math problem in your head while holding numbers in your mind and so on. So, actively you can manipulate things and solve problems and so on. Now comes the long term memory. The last component of memory is long term memory. So, as the information transfer from short term to long term memory, especially when you rehearse it, you pay a lot of attention and you kind of process the information deeply and rehearse it, then the information goes from short term memory to long term memory, which has an almost unlimited capacity, where it is encoded and stored for future retrieval. Long term memory is the part of the memory system responsible for storing information over long periods, from minutes and hours to years and lifetime. It can store information for very long time. It can be for minutes also. Sometimes some long term memory they just vanishes also. Unlike short term memory, long term memory has practically unlimited capacity and supports our knowledge of facts, personal life events, skills and condition response. So, we human being has so many informations. We have so many skills, so many knowledge and so on. All these are because of the large capacity of the long term memory. We could store almost unlimited capacity. What is the evidence for long term memory as a separate system from short term memory and sensory memory? How do you know there is something called as a long term memory? So, there are many evidences available. Psychologist Brenda Milner in 1966 studied a patient with brain damage, such as the famous case of HM. After his surgery, HM could remember things that happened before the operation. Old memories he could remember, but he could not form new long term memories. So, this was a patient with certain because of certain brain damage, the patient had after the surgery had developed certain condition, and condition was that the patient could remember old memories before the surgery. He could remember whatever happened before the surgery, but after the surgery he could not form new long term memories, he could not form new memories for very brief time, and then he used to decay. So, this shows the short term memory was still working because he could process information for short term and kind of respond to the situation. So, he could hold information for short term that was visible in his working, but he could not form new information. No. So, he could only hold information very briefly. His long term memory system was damaged. He could not store that new information permanently. So, that was the problem. So, that means the brain had different systems. Short term was working, long term memory was not working. So, this clearly shows that brain has different subsystems. So, thus ability to retain old memories, but fail to form new ones provide the evidence that short term memory and long term memory operate as a separate system in the brain, because one was working, another was not working. So, they are separate system. If they are both are one, so both will be affected, but here that was not the case. One was working, one was not working. So, that means they are separate systems. Then laboratory studies also further supported this distinction. For example, in classic experiments, participant asked to remember simple items, for example, 3 letters, showed a rapid decline in recall when distracted by counting backwards, suggesting that distraction prevented information from entering long term. So, when people were asked in the experiment to remember some items, 3-4 items for example, they could not rapidly, they could not remember a lot of these items when they were asked, distracted by, let us say, count backwards and then you recall, because they could not rehearse it. So, their information did not go from short term to long term memory. They could not report correctly a lot of times, because when their distraction was given. So, this reflected short term memory was there, which got fed quickly, but it did not transfer into long term memory. So, this also proves, experimental evidences proves also different systems. Additional evidence also comes from something called as a serial position effect, which we will also discussed in the next class, next or one of the lecture of the memory, where recall depends on an item position in the list. Early items are remembered better because of primacy effect. You are able to remember better whenever a list of item is given to you, remember, let us say 10 items are given you to remember. Generally, people are better at remembering initial item, few items, 3-4 items, and then the end items, like last 3-4 items. People generally are not able to remember the middle items in a better way. So, beginning and the end items are generally remembered better when a list of items are given for remembering. So, that is called serial position effect. So, because this is something called as primacy effect, because you are able to give, whenever you read a list, initial few items are given more importance, you pay more attention. So, they are remembered better. So, this is called primacy effect. Last items are remembered better because they are more recent, just you have read them. So, they are called recency effect. So, primary arises because early items receive more importance in rehearsal and thus more likely to be encoded in the long term memory. Recency reflects items are still in the short term working memory and maybe you are still remembering them. So, these two components shape the curve supports the two stores and processes. So, this also kind of shows that there are two different systems that people are able to recall something and not able to recall something. Maybe there are two different because of the differences in the systems. Now, long term memory is also not just one unitary thing, there are different subsystems to it. So, there are different types of long term memory. Just as we found different subsystem in the short term memory, long term memory also has different subsystems, several different components called memory modules. Each of these modules represent a separate memory system in the brain. So, within the long term also there are separate systems, just like short term memory had working memory had subsystems, not the short term memory, working memory has subsystems. Similarly, long term memory also has subsystems. Long term memory is not a single store, but broadly divided into two broad categories. One is called as an explicit or declarative memory and second type is called implicit or non-declarative memory. So, you have two types of long term memory. One is declarative or explicit memory, which are about conscious intentional recollection of facts and events. When you are able to remember some facts, some events that happened in your life, you are able to have some general knowledge about the world. These are all declarative memory or explicit memory. You can consciously, intentionally remember them. On the other hand, non-declarative or implicit memory are generally unconscious automatic memory for skills and procedure. So, these are like automatic memory, some of the things you consciously do not remember them. For example, once you learn to drive bicycle, you do not remember every time when you drive a bicycle what kind of steps should be followed, automatically it happens unconsciously. These are called implicit memory or non-declarative memory. You do not have to remember all the steps again and again, it happens automatically. So, broadly they are called, long term memory has declarative memory, knowledge system, facts and knowledges, and non-declarative memory, all the memory that are generally unconscious automatic memory skills, mostly for the skills and the procedure that we learn in to do something. So, let us look into explicit or declarative memory. Again it has many subsystems. So, if you see long term memory, so it has declarative and non-declarative. Again the declarative has other components, non-declarative has other components that we will talk about. So, declarative, now let us look into the declarative part and what are its subtypes. So, declarative is memory involves information that can be consciously recalled and declared, such as names, dates, events. We know the names of people, we know the dates of many things, and we also know when some event happened, what are the events happened in our life or someone else's life, whatever. These are all facts and knowledge system that we all remember. These are called declarative memory. It depends heavily on the hippocampus part of the brain and related to medial temporal structures. So, these are all facts and knowledges that we learn. These are all called declarative memory because we consciously remember them. This has subtypes. One is called semantic memory. Semantic memory is memory of facts and general knowledge, meaning and concepts that tied to personal experiences. Whatever facts we know, whatever knowledge system we have, whatever the meanings and concept that we learn. So, education, for example, through education we generally learn a lot of semantic memory, develop semantic memory. We learn a lot of facts, knowledge structures, a lot of meanings and concepts. These are all semantic memory. For example, knowing Paris is the capital of France, 2 plus 2 is 4, that a dog is a mammal, these are all facts and knowledges, these all comes under semantic memory. Key features, what are the key features? It is impersonal and context free. It is generally not tied to any context, these are neutral facts that we learn. You know it, but you do not necessarily remember when and where you learn it. You may not remember where you learned what is the capital of France. You may have learned it somewhere something, but you may not remember the context where you learned it. So, typically brain area, temporal and frontal lobes are responsible for semantic memory. So, this is a part of declarative memory. Then comes episodic memory. Episodic memories are also declarative memory. Here it is about specific personal experiences, events situated in time and place. Remembering things about some episodes of events that happened, some personal experiences that happened in certain dates, certain times, certain places. So, these are all episodes that we remember, episodes of our life that we remember. So, remembering your first day at school, at your last birthday party, what you ate for dinner last night, these are all example of episodes of your life. Some things happened in your life. So, these are called episodic memory. These are not knowledge and facts. These are things, maybe factual, lot of this information, but these are the things or episodes that happened in your life. So, this may be related to autobiographical and time stamped, you can relive it. So, these are all contextual information. Now, you know when you celebrated your last birthday, so some context and time you may remember. So, you can relive them mentally, So, these are episodes that happened in your life. Hippocampus and medial temporal lobe generally are responsible for episodic memory. So, together semantic and episodic memory form declarative memory. So, long term memory has one category called declarative memory. Declarative memory has two subtypes, one is semantic and episodic memory. Now, this people also sometimes based on from where the information you are remembering, this declarative memory can also be categorized as retrospective memory or prospective memory depending on from which time period you are remembering information, for which time period. Retrospective memory refers to remembering information, events from the past. It can involve both episodes and semantic information. Whenever you remember anything from the past, that is called retrospective memory. It can involve episodic or semantic information. Whatever you learned in the past, It could be semantic information, any knowledge, facts, or any episodes that happened in your life in the past. So, this can include both the categories of declarative memory in the retrospective memory. So, remember what you studied last night, recalling your graduation day, remembering what you already paid a bill and so on. So, looking backward in time is retrospective memory. These are another way of kind of categorizing based on the time period. Prospective memory is about remembering something that will happen in the future. Prospective memory involves remembering to perform intended action in the future. So, you have some intention to do something, let us say tomorrow or after 1 week, after 1 month, you remember I need to do this in the future. So, those are called prospective memory. For example, remembering to take your medicine at 8 p.m., remembering to attend a meeting tomorrow, send a message later and so on. These are all prospective memory. You create an intention to do something in the future and you remember it. So, it is about looking forward in time. So, typically prefrontal cortex and hippocampus is kind of part of the brain is responsible for prospective memory. So, these are all part of again declarative memory, but categorizing it based on the time period. So, if you see long term memory has one is declarative memory, one is non-declarative memory. So, now declarative memory has again two parts based on types, we can say semantic memory, episodic memory. Semantic is about facts, knowledge and so on. Episodic is about personal experiences that tied to certain episodes of your life, like your first date, whatever it is, certain episodes in your life. The same declarative memory we can also categorize based on the time period. We can categorize it as a retrospective memory if you remember something from the past, what did I ate for dinner last night, or prospective memory if we remember something or some intention to do something in the future, memory of future actions. What is, let us say you have tomorrow a doctor's appointment and so on. So, this is called declarative memory. Autobiographical memory is another category of memory that is generally people discuss as a separate category that comes under declarative memory only. So, this is also another aspect of memory which is discussed, but generally it comes under declarative memory. So, it is a combination of episodic and semantic memory which is part of declarative memory only about your own life, autobiographical. Now, declarative semantic memory in general it includes all the knowledge facts about anything. Here episodic, your own episodic life experiences, your own life only and the knowledge and facts about your own life. When you combine them, it becomes an autobiographical memory, memory of your own life. For example, remembering where you went in your honeymoon or knowing the name of the first school and so on, these are all only typically related to your own life, then it becomes an autobiographical memory, memory of your own life, events, facts of your own life. So, everybody's life has both factual information and episodic information. When both are combined about your own life, it becomes an autobiographical memory. So, personal, long term, emotionally rich information that we remember about our own life is called autobiographical memory. Again, this is just part of the declarative memory only. The last one is called as a non-declarative memory or implicit memory. So, these are those memory which are unconscious, you do not consciously have to remember them. These are all related to mostly the procedure and the task that we learn to do, some skills that we learn to do, mostly they happens very automatically without conscious awareness. It also includes the different subtypes. It is largely supported by basal ganglia, cerebellum, motor cortex. These are the part which are responsible for non-declarative memory. Subtypes include procedural memory, memory for skills, habits and action that are performed automatically after learning. Broadly, non-declarative memory is about procedural memory. So, you learn lot of skills like riding bicycles, driving a car, driving a scooter. We have so many habits that happens automatically, you do not remember them, you do not have to step by step remember, automatically this thing happens. So, a lot of these actions performed automatically after learning. Once you learn, then it becomes automatic. These are all called procedural memory. For example, riding a bicycle, typing on the keyboard, playing the piano or tying shoelaces. Once you learn, then they becomes automatic. So, these are all procedural memory. It improves with practice and is retained even when explicit memory lost. Many patients who lost declarative memory or explicit memory, they forget all the facts and episodes of their life, but still they can do this procedural memory remain active. They may still learn to ride bicycle, but they may forget everything about their life. or whatever that happened after an incident. So, all the other memory can get lost, still their procedural memory can remain intact, and these evidences are available in many patients. So, this shows this is a separate system. Sometimes in some other forms this implicit memory or non-declarative memory is also kind of experienced, one is called priming. So, what is happening in priming? Exposure to one stimulus influences the response to another, often unconsciously. When you are exposed to something and something else comes later, that earlier exposure influences you automatically. So, that is called priming. You just become primed because something was exposed to you. For example, after reading the word yellow, you are faster to recognize the word banana, because yellow prompted you, made you more ready to look at things which are yellow. So, you are more likely to remember banana or recognize banana because yellow was presented to you first. So, yellow is primed and this yellow will influence your next behavior automatically. So, this is called priming. Okay? So, that is called priming, that is also a part of non-declarative memory. Classical conditioning that we discuss also involve memory of like non-declarative memory. When you learn to associate things, two things, a neutral thing become conditioned, you learn a new response that we discussed elaborately in the earlier module. So, learning by association where neutral stimulus becomes linked to a meaningful one, as we discussed earlier. For example, salivating when you hear the sound of a bell if it has been repeatedly paired with food, as in Pavlov experiment. This is also becomes automatic habitual kind of responses that can be kind of categorized under non-declarative or implicit memory. So, these are again kind of summarized. So, long term memory, one is declarative, one is non-declarative. Declarative has again types wise semantic memory, episodic memory, time frame wise retrospective memory, prospective memory. Implicit memory or non-declarative memory is procedural, then priming, exposure effect, priming means exposure effect, then classical conditioning means learning associations and so on. So, these are kind of summary of what we have discussed now. So, these are all kind of introductory concept about different types of memory and their functions. So, with this I stop here, I will talk about other things in the next class. Thank you.